So delta to y conversion. What's a delta to y? Well, you could have, and this is back and forth, delta to y and y to delta. If you have a delta like this, and we'll call this I don't know, RA, RB, and this is RC. And you want to change that to Y. Y will look like this. We'll call this R1, R2, R3. So you are given, so the first one we're doing delta to Y. So you actually know, the value of R sub A, R sub B, and R sub C, and you want to find R1, R2, R3.
And it'd be the same for reverse.
Reverse, you'll be given R1, R2, R3. You want to find RA, RB, and RC. And if I look in my drawer from last year, I probably have that sheet somewhere, because I use that a lot and I keep it handy. Somewhere here, if I go through my scrap paper, because I have a lot of scrap paper, flip some of these, oh, what do you know? This is from last semester. Delta to y, y to delta. So if you want to find the y value, so R1, we'll call this R sub 1. I find actually there's a pattern if you look at it. Look where R sub 1. R sub 1, the 2 next to it is what? R sub A and R sub B based on my picture. So you multiply these two over the sum of all three of them. If I'm looking for R sub 2, this is R sub 2. I'm going to multiply the two surrounding ones, which is what? RA times R sub C over the sum of all three of them. And if I'm looking for R sub 3, the two adjacent to R sub 3 are what? RC and RB. Just a quick reminder, I drew the delta looking like this. Most of the time in our book, they draw the delta looking like this. That's what it looks like.
And what would R1, R2, and R3 be?
It will look like this.
So this is like a way to convert from like that.
From this to this.
Okay.
But like when I do a delta, I always do a triangle. Don't be surprised if our book doesn't look like a pi shape. Like pi 3.14, the top and the bottom. That's what it looks like, the top and the two sides. That's R sub y. Notice if you just move them up there, that's what you have. You have that shape there. And again, if you take these wires, instead of like on angle, make them go straight, make this one go straight, and just attach them with the wire. So when you see this, a lot of people don't recognize this is actually a delta and that's a Y. But that's really what that is. That's a delta and that's a Y.
What's the advantage of doing this?
What advantage of which one? The conversion?
Yeah.
Oh, you'll see an example in a few minutes. When I give you one, it makes the math a lot easier to solve it. You know, I feel like the advantage why you draw them like triangle versus this shape. It's just some people like everything to be like 90 degrees straight and neat. If you're that type, instead of doing this triangle, you can do that. Instead of this Y, you can do this. Now the other one, if you have Y and you want to go to delta, so you actually know, let me draw Y, it looks like this. What did I call them? R1 here? I don't know. R1, R2, R3. So you know R1, R2, and R3, and you want to find RA, RB, and RC. So now you want to find what R sub A, the red is what you're trying to find, and I did R sub B down here. And this is R sub C. So if I'm looking for R sub A, I'm going to do R1 times R sub 2 plus R sub 2 times R sub 3. I use 1 and 2, 2 and 3, and 3 and 1. Plus R3 times R sub 1. So this times this, plus this times this, plus this times that, divided by, this is R sub A. What is opposite to R sub A is which resistor? R sub 3. If I'm looking for R sub B, the top is always the same. It's R sub 1, R sub 2, plus R sub 2, R sub 3, plus R sub 3, R sub 1. What is opposite to R sub B? R sub 2. And if I'm looking for R sub C, opposite to R sub C is R sub 1. I didn't do a good job drawing this picture. I like my picture from last semester. I get them different names. After you finish, I'll put that picture up there. The first one I did okay job with it. Like the picture, it wasn't bad at all. It was nice. So this one, like the crooked, and didn't do a good job with it. So last semester when I did the course, I summarized them on one page like this. Now, so I'm going to keep that page handy. So I'm probably still going to pull that sheet of paper and use it all the time. And if you're watching this on video, I recommend to people, because they ask me if they can have copies of the notes. I recommend freeze your video right now, take your iPhone, take a picture of it and print it. You know, because it says, you know, you go buy them quickly, or you can freeze it and just rewrite that. Stop the video and type this. They're looking for R sub 1, R sub 2, R sub 3. This is Y. If you have Y, which is you have that. Notice that's an upside down Y, because it looks like a Y like this, capital Y. That's an upside down Y. You go into delta, that triangle. This one, you're given the triangle. and you want to find the y, again, the way I drew these upside down. And it doesn't really matter here. That looks like a y, capital Y. See, that's why they call it the y. It's capital Y. That's the delta triangle. So delta 2y. It looks like this. You're going from this, the triangle, to y.
I thought that was some guy named the Y that found.
Nope.
the sound.
Just the letter y in delta. You know, delta always means a triangle. This one is from capital Y to delta. So the question, I think Luke was you asked, why or what do we use this? How is that going to help us? So let's take an example, and let's say I want to analyze a circuit.
Now, when we're on the test, are we allowed to like change, like you said we're gonna have to use certain methods, but are we allowed to like change the circuits around at all before we?
You can change them, sure. Some of the stuff, I mean, if I say use mesh, and you have to use mesh in that equation, but if you want to redraw it and combine maybe color resistors together, you know, just to make it easier, probably allow you to do that, yeah. But I still want to use mesh analysis. Show me you know how to use mesh. Show me how to use it. You can look at some of them, probably say, this is not the best way of doing it. And on that test, I don't really care for the best way. I'm looking to see if you know all the techniques. Later, you'll know this method, if I use this method, that's quicker than this, or the algebra is easier. That's fine. So let's take an example. I'll go to the back of the book. I'll find an example. I go, oh, let's see. What can I do with this? See if I can find one with y and delta in it. Here's one. I'll just start with this. I have this circuit. It has 100 ohm here. This is R. I'm not telling you what R is. This is 200 ohms. This is 68 ohms. This is 42 ohms. Find R, find the value for R. That will make R equivalent. EQ, also. The equivalent R, looking at the circuit, equals 70.6 ohm. So if you're looking back in this direction, we'll find the equivalent, R equivalent. What value can I put for R here that will make it 70.6? You go, oh, let me just simplify. Well, let's look at this resistor and that resistor. How are they connected? Are they in series or in parallel? These two.
Parallel.
Try again. Neither. It's not, to be in parallel, that means they're going to be connected here and connected at that end. So these two are not in series or in parallel. There's not much you can do to it. But if I take the bottom, that looks like a delta, doesn't it? If I take that bottom and change it to a y, if I do that, and I'll call it R1, R2, R3, I will be able to take that circuit that you see on the top and now the y value will be what? R1, this is what? R2 based on my picture, R3, and that will be R equivalent. And I want that to be 70.6. And I should be able to combine these two because they're going to be connected how? And I should be able to combine these two because they're connected in series.
Is that top circuit or Wheatstone Ridge?
Ridge?
Is the top circuit or Wheatstone Ridge circuit?
Ah. Why?
It looks familiar.
Yep.
What is it? Wheatstone Ridge?
Don't worry. Don't worry. We'll be talking about bridges. Okay. How can I find where R sub 1 is?
R sub 1 is
You multiply the two surrounding one over the sum of them, right? R sub 1, the two surrounding is 200 times 42 over the sum of them. 200 plus 42 plus 68. Is that 300 in the bottom?
no,
Or more?
310.
310? So let's see what that number is. 200 times 42 divided by 310. 27 roughly. 27.09.1. 27 is good. What's R sub 2? 200 times 68 over the sum of them. $200 times 68 divided by 310. 43.87, approximately what? 44, if I use a whole number. You want to use decimal 44.9 here. The other one, 27.1, if you're worried about that decimal. That's 43.9, not 44. If you want to carry one decimal place. And what's R sub 3? 68 times 42, right?
110 over 310.
110? That's a multiplication on the top, right?
Never mind, sorry.
68 times the 42 divided by 310. 9.2. R sub 1, 27.1. This is 43.9. Now you can combine these two into one resistor. I can make it look a little bit nicer now too. What's 100 plus 27? 127.1. Instead of having that little dent in it, I can make it look like this. This is 43.9 plus R, because you got to add them. 9.2. Now, how are these two connected?
Parallel.
Parallel. Product over the sum. So that'll be 127.1 times 43.9 plus R over the sum of them. A little math here, 127.1 times 43.9, 5579.7 plus 127.1 R over the sum of them, 127.1 plus 43.9. It's 171 plus R. And how is that result in relation to this one?
78.6 minus 9.2.
Yes. So this is going to be in series with that. So we take this answer, add to it the 9.2, because they are in series, and that result should equal 70.6. So move the 9.2 to the other side, becomes a minus. $70.6 minus 9.2 is 61.4. That's over 1. And now we're just going to solve for r. When you have a fraction on the left, fraction on the right, the easiest way is what? Cross multiply. This times this should equal this times that. That's the easiest way. 1 times the top is the top. 5579.7 plus 127.1r should equal 61.4 times 171 plus r. $61.4 times 171 on the right side. So I have 10499.4 plus 61.4r equals 5579.7 plus 127.1r. All the r's on one side, all the numbers on the opposite side. 127.1r minus 61.4r equals 10499.4 minus 5579.7. Do the right side, we have 4919.7, 127.1 minus 61.4, 65.7r, and to get r is going to be what? That number divided by this?
74.88.
70.4488. So 74 you mean?
Yes.
74.9 ohm, or 75 ohms roughly. And notice with that delta to y, I'll be really stuck there. I'll be like, what do I do now? You know? So when you have a problem like this, and again, I could have took this problem here and go, oh, simplify this. You can take this triangle here, the delta, can you see it? And convert that to y. Will be 1, 2, 3. And you can see now that y, you'll be able to open them. Or you can take this delta that you see up there, replace it with y. And see which one makes the problem easier. There's another delta right here. I don't know if you can see it. There's a delta right here. Can you see that? That's a delta. That's also a delta, right there. That's a delta. This is a delta. This bottom half is a delta. So which one makes the problem easier? Start going through them one by one. Let's see what makes the problem easier. As I said, you'll see a problem like this. You'll never think that's a delta. But that's a delta. This is a y. You either do it like this or like this one. There's a lot of them right here, delta. You can just chop that piece right there. Go, that's a delta. Or take the bottom. Oh no, that's not, because you have that resistor here. But I could have took just this piece and made that a y. Or I could have took, well, I get connection here. But I could have took that piece without that resistor. Nope, that's not, because it has to be
The
connected.
right side?
I can do this actually. That's a y. That's a delta, change it to a y. You see them right here. Problem like this. Convert that to y. The top half. Once you do that, you'll be able to combine that resistor, the newer one, with this. So you'll be able to simplify it. And notice the question came up early. Could I have done source transformation right here? Absolutely. Right? And I could make a current source in parallel with that and combine the two of them, make it one resistor. I can still do all the stuff I learned, but also I can use y to delta to y to shrink that problem a little bit. So there's a lot of need for y to delta and delta to y. Again, make sure you have that equation or those just transformations somewhere handy. Allows you to go from delta to y and y to delta if you ever need them. I'm going to leave this in the drawer right here because that's a nice clean one. I have them both on one page. You know, I'm going to keep mine handy. And you are welcome if you want to come take a picture of it and print it. You can do that. You know. Okay. So that's the last piece actually of that chapter, chapter 5, delta to y and y to delta conversion. I'll stop here.